Hey everyone, and welcome back to the AI YouTube channel. In today's video, we're delving into the world of machine learning. Machine learning is a subset of artificial intelligence that enables computers to learn and improve from experience without being explicitly programmed. Machine learning algorithms do this by using data to identify patterns and make predictions or decisions without relying on rules-based programming. It's an exciting and rapidly developing field of artificial intelligence. So today we're going to look at how machine learning works, its history, and the important differences between machine learning, deep learning, and neural networks. Let's get into it. Machine learning is a way of creating computer programs that can teach themselves and progressively improve through experience. At their core, machine learning programs have three main components. The first is a decision-making part that makes predictions or categorizations based on data patterns it observes. These could be patterns in labeled data or unlabeled data that the program tries to structure into meaningful groups. The second is an error detection part that compares the program's decisions or predictions to known examples in order to assess its accuracy. This process helps the program measure how well or poorly it's performing. And finally, there's an optimization element that fine-tunes the program by adjusting its internal settings until its predictions reliably match the known examples. It's essentially trial and error until the program reaches a desired level of accuracy. By repeating this evaluation and refinement process over more data inputs, machine learning programs can progressively enhance their performance and extend their capabilities over time without the need for explicit reprogramming. Businesses can then use these increasingly capable machine learning systems to unlock valuable insights from data at far greater speed, scale, and precision. So now we know how machine learning works, let's take a quick look at the history of the field. Machine learning's journey began all the way back in 1842. Ada Lovelace, the world's first computer programmer, created an algorithm where she described a sequence of operations to help solve mathematical problems. The next breakthrough came in 1936 when Alan Turing theorized how machines might decode and execute a set of instructions, with his published work becoming what's considered the basis for computer science. In 1943, a neural network was modeled through electrical circuits, which became the base for computer scientists to apply in the 1950s. Then in 1950, Alan Turing created the Turing test, which determined whether a computer has real intelligence. In order to pass this test, computers had to be able to fool humans into believing that they were also human. The first computer learning program was developed by Arthur Samuel in 1952. A forerunner to IBM's Watson computer, it improved in its ability to play checkers the more times it played. In 1957, the first neural network, which simulated how humans think, was designed by Frank Rosenblatt. Then, a decade later, in 1967, computers started being able to do very basic pattern recognition as the nearest neighbor algorithm was written. This algorithm could map routes for traveling salesmen, allowing them to visit more cities in a shorter period of time. Fast forward to 1981, the concept of explanation-based learning was introduced by Gerald de Jong. It lets computers analyze training data to create general rules to follow and discards unimportant information. In 1999, the CAD prototype intelligent workstation was developed by the University of Chicago. It reviewed 22,000 mammograms and was able to detect cancer with 52% more accuracy than radiologists. In 2006, Geoffrey Hinton, a computer scientist, rebranded net research as deep learning. And most recently, in 2016, North Face became the first retailer to use IBM Watson's natural language processing on a mobile app. Customers could use it as a personal shopper to help them find the clothes they wanted. Machine learning, deep learning, and neural networks are often used interchangeably. However, they have distinct differences. In fact, deep learning is a subfield of machine learning, and neural networks is a subfield of deep learning. The difference between machine learning and deep learning is how each algorithm learns. With deep learning, the feature extraction part of the process is automated, allowing for larger data sets to be used. Deep machine learning is able to leverage labeled data sets or supervised learning to provide information to its algorithm. It doesn't need any human intervention when processing data, which allows for a different scalability of machine learning. Neural networks, also known as artificial neural networks, are made of node layers, which have an input layer and an output layer. Each of the nodes connect to other nodes and they have an associated threshold and weight. The node is activated if a node output goes over a specified threshold, and it sends information to the next layer of the network. The deep part in deep learning refers to the neural network layer depth. A neural network that has more than 3 layers can be seen as a deep neural network or a deep learning algorithm. If it has just 2 or 3 layers, then it's just a basic neural network. And there you have it, the basics and history of machine learning. The journey of machine learning is still very much ongoing with new developments and breakthroughs happening all the time. It's an exciting field that holds endless possibilities for the future. We hope this video has given you a deeper understanding of machine learning and its incredible potential. Don't forget to like, share and subscribe for more content just like this. Thanks for watching and see you next time.